Well, hello Internet, and welcome to part 2 of my CoffeeScript video tutorial. In just 2 video tutorials, I'm going to teach you all the basic syntax you need to start writing CoffeeScript code right now. If you didn't watch part 1, you should definitely watch that, and I provide a link here on the screen as well as in the description, because otherwise you might be quite confused. And like always, all the code's available for free in the description under the video. So I have a lot to do, so let's get into it. Okay, so here we are once again. Over here we have Sublime Text, over here we have Google Chrome, and over here we have the terminal or command line if you're using Windows. And if I want to shut that off and reload it, I can come in here, and this code right here inside of my terminal is going to automatically compile all my CoffeeScript code for me. So I'm going to run that, and of course it's going to compile in a regular JavaScript. Now the very first thing I want to talk about are arrays. Now arrays inside of CoffeeScript, just like JavaScript, can contain multiple data types or just one data type. So we'll just create a random array here, and I can throw a string inside of it, I can throw a boolean inside of it, I could throw an integer inside of it, and I could throw a floating point number, and that's going to be perfectly fine. Now I'm going to be able to come in here, and let's say that I want the second index inside of this array. String interpolation is going to be used again, and I'm going to say random array and 2, and save that. You can see it compiled down here and reload, and you can see that index 2, 1, 2, 3, 4 pops up. Of course this is 0, 1, 2, 3. That's how everything is set up. I could also come in and use a range. So let's say that I wanted the second and third indexes. I could get those as well. So let's just change this to last 2 and reload it. You can see that they display there with a comma in between both of them. We're also going to be able to define arrays that are made up of ranges. So let's say I wanted to go 1 to 10. How I would do that is just create a range from 1 to 10. Also, I could do the same thing. I could create another array that's backwards. So I could say 2 to 1 is equal to, and then put 10 dot dot 1, and that would create that for me. I could then come in and combine these arrays. So let's say combined array is equal to, and I could go 1 to 10, concat, followed by 10 to 1, and that's going to combine those guys for me. I could then push 10 to 1 onto the end of 1 to 10, and how I would do that is I would go 1 to 10, and then push, and then 10 to 1. And then I'm going to put 1, 2, 3, and what this is called is a splat. And you're going to be able to use it to indicate that you want to soak up a list of arguments or all the values that are currently inside of our array. I'm going to come through here with a for loop and cycle through that array so you can see what that looks like. So for x in 1 to 10, obviously it's not going to be 1 to 10 anymore. You can see the white space was handled there for me. And I can output this, and then we'll just keep this very simple, and I'm just going to throw x inside of there like that and reload it, and you can see all of the changes we made to our array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10, 9, da 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 da. And that all came about because I pushed 10 to 1 onto the end of 1 to 10. I'm also going to be able to come in here and convert our array into a string, and how I would do that is, again, I'm going to use string interpolation, and I'm going to say 1 to 10, and then I'm going to say 2 string, and put my parentheses on the end there, and reload, and you can see that it went and automatically converted that into a string all on one line. Now let's get into some cool stuff. So let's say that I want to filter out all the odds by saving elements that return true for a condition. So let's say that I want evens only. How I would do that is I would say 1 to 10, and then I'm going to say filter, and what I want to filter here is x, and the condition in which a number is going to end up in the even only array is going to be based off of x modulus 2. Whenever that's equal to 0, that means if out of this array, if in any situation one of those items comes back as equal to 0 whenever you take the modulus of 2 of it, it's going to be stored inside of that array. And to see that that indeed is true, let's come over here and output this, evens only, and let's just go and use 2 string again, and you can see only the even numbers print out in that situation. So it's very easy to filter out and get certain types of information with CoffeeScript, which is really cool. We're also going to be able to come in here and easily get the maximum number inside of there. So let's just say max, and you can use all of your JavaScript functions that you're very well aware of. So we'll say math max 1 to 10, and then we'll use a splat again, which just means that I want all the items inside of the array. Reload it, and you can see the maximum number comes out as 10. And of course, if we're able to get the maximum number, we're also going to be able to come in and get the minimum number by just changing this to min. We'll change that to min so it all makes sense. Reload, and you can see 1 comes back. So now let's do something a little bit cooler. Let's sum all of the items inside of our array. So to do that, we'll just say 1 to 10 once again, and we'll reduce that down. And what we're going to do is, as we cycle through, we're going to get the x and y, and what we're going to do from that point is sum x and y as we cycle through our array. Come down here, type in sum, and then sum of array. Reload, and you can see that that worked. And you could do numerous different types of mathematical operations in that situation. We could also come through and reverse our array, change that to reverse. And let's say that we just want to reverse 10 to 1, reverse, reload, and you can see that we went and reversed it. And the reason why it looks like it's in the proper order is this is 10 to 1, not 1 to 10, so you can see how that works out. So why don't we come in here and create an array of objects. So we can create a people array. I'm going to get more into objects here in a second. And of course, with CoffeeScript, we're going to be able to come in here, and we don't need to use commas if we don't want to. So we could say name and Paul, and age, and 43. Throw a comma right there, and then we'll do the same thing with another one of these guys. We'll say name is Sue, and age is 39. Now we're going to be able to come in here and access our items by the key inside of the array. So let's say I want to get first name. I could then come in here and go people array, and let's say that I want the very first objects inside of it, and I want to get the key for name that matches up with that. And you can see first name Paul pops up, just as we would expect. And that is a basic overview of how we're going to use arrays inside of CoffeeScript. I'm going to get a little bit more into them as this tutorial continues, but now I want to jump over and talk more about looping. I'm going to keep 1 to 10 here, the array, so that we'll be able to play around with that. And I'm first going to, of course, come in here and recover how to cycle through an array. So to do so, we just go 1 to 10 like this, and then we're going to output that information. And let's just keep it simple and just put x inside of here. And you can see that that indeed works. We're also going to be able to use guard statements if we wanted to maybe only print out odd numbers. And to do that, we just go for x in 1 to 10 when, and we'll say x modulus 2. And you could also use isn't instead of equals or not equal to. There's just a ton of different things built into CoffeeScript that we're going to be able to use here. And then we'll just keep this simple and print out x. And if we reload that, you can see it cycled through there and only printed out the odd numbers. So that's how guards work, as well as isn't. We're also going to be able to cycle through ranges of numbers. So let's say 4x in, and let's say that we wanted to cycle through 50 to 100 when x modulus 2 is equal to 0. We can do that, and then we'll throw x inside of there and get rid of this so it doesn't confuse anybody. And you can see that it went through, and because we used is instead of isn't, it's going to show all of our even numbers in that situation. We're also going to be able to output information as we skip certain information. So we'll use 20 to 40 in this situation, and we'll say that we want to skip every 2 items. Throw x inside of there and reload it, and you can see there we printed out just the even numbers. So there's a whole bunch of different ways we can cycle through arrays. Now let's create an employees array. Once again, we do not need to use commas if we don't want to, so we can say Doug, Sue, Paul, and then we're going to be able to print out the indexes as well as the information that's stored inside of it. So let's say we wanted to say something like employee and employee index in the employees array, and we wanted to output some information in regards to that. So we could say that we wanted to get the index number plus, and we could get employee index plus the employee plus, and then we could get the individual employee name plus, and have a break statement, reload it, and you can see that we were able to get the index as well as the individual piece of information that was stored inside of it just that way. We're also going to be able to come in here and search for values that are inside of our array. So we could say if Doug in employees, and then perform an operation based off of that. And I could just keep it simple and just say I found Doug. And you can see I found Doug shows up there. And another thing we can do is not only can we use for loops, we also have the option of using a while loop, even though they're not used very often. So let's say I want to count from 100 to 110 with a while loop. This is how I would do it. I could say while, and then here what I'm going to do is define the changing value of I as it cycles through the array. And then here I'm going to say when I want to stop cycling through the array. So as long as I is less than or equal to 110, we're going to continue outputting information on the screen. And I could just say I is equal to, and then throw the value of I inside of here, reload it, and you can see that it went and cycled through that and stopped whenever it got to 110. We could also create another while loop that's going to cycle until 0 is reached. So let's say we wanted to do something like monkeys is equal to 10, do the little nursery rhyme thing. We could say while monkeys minus equal to 1. Since we want it to stop whenever monkeys gets to the value of 0, we don't need to come in here and put any conditions inside of it like we did before. And we could output some information. And there's a little nursery rhyme where the monkeys jump on the bed until they fall off and supposedly die, I guess. I don't know. There we go. So we'll just go 9 little monkeys jumping on the bed, 1 fell off and bumped his head, 8 little monkeys jumping on the bed, 1 fell off and bumped his head, and we continue doing that until there are no monkeys. It's a very sad story, but kids like it for some reason. So there's another example of how we can use a while loop. And also we can pretty much fabricate a do while loop even though there's nothing inside of here that allows us specifically to create a do while loop. And how you would do that is go x is equal to 0 and then say loop and then output some type of information. So let's come in here and get rid of that. And then let's say that I want to increment the value of x inside of here. And then thereafter break unless x is not equal to 5. So it's going to cycle through this as long as this condition is not true. And you can see it printed out 1, 2, 3, 4, 5. So there's an idea of how you could create a do while loop if you definitely felt like you needed one. So there's an overview of looping inside of CoffeeScript. Now we're going to take a look at functions. Okay, so now let's talk about something cool, which are functions inside of CoffeeScript. One rule you need to know is that you're going to have to define your functions in CoffeeScript before you use them. So you're either going to have to put them at the top of your file or you're going to have to include them from a separate file. And to define your functions, you're going to have a function name first. So we'll go hello function like this, followed by an equal sign. And then you're going to have inside of that any attributes your functions are going to receive, followed by an arrow sign like this. Then you're going to either put in a return like this. I'm going to show you an alternative way you can do this, and then followed by whatever information you want to output. Now we can come in and call this function just with string interpolation and hello function and pass in my name, for example, and reload it. And you're going to see that hello Derek pops up there. Now, of course, you're also going to be able to use functions that do not receive any attributes. So you could say something like get random number equal to, don't forget to your equal sign, and arrow like this, and return math floor. Say we want to generate a random number here from 100 to 1. We're going to be able to do that. And then we could come in and just create random number and then call get random num with our parentheses like this and reload. And you're going to see it generated a random number. Another thing you're going to be able to do that I didn't mention before is whatever the last value is inside of your function, you're not going to necessarily have to use return to have it returned. As you can see right there, hello Derek pops back up, and that can become very useful. You're also going to be able to receive an undefined number of values. So let's say I wanted to sum, no matter how many numbers come in here, sum numbers, and I'm going to say vars, and I'm going to throw a splat in there, which means everything, or soak up everything that is in the vars attribute. And then I could say something like sum is equal to 0, and then cycle through this in vars, and then sum plus equals to x. And in this situation, we will have to return the sum, but we will be able to come in here and sum this number. So we'll say sum, and then pass in as many things as we'd like. So sum numbers, 1, 2, 3, 4, 5, doesn't matter, as many as you want. Reload it, and it's going to automatically sum those no matter how many different attributes you pass in. Now, like I said previously, the last expression in a function is going to be returned by default. So let's say we had something like movie rank equal to, here's an attribute. You could also define a default value for an attribute just like this. And then we could say if stars is less than or equal to 2, then we want to return bad, else we want to return good. Let's go and output that information. So you can say movie rank, and then we'll call our movie rank function and not pass anything into it, just to show you that the default value of 1 is going to work for us, and movie rank comes back as bad. If instead we changed it to 4, movie rank is equal to good. Also going to be able to use recursive functions, which are just functions that call themselves. So factorial, for example, we can go in here and calculate. So we can go x, and then what we're going to do here is return 0 if x is less than 0, return 1 if x is equal to 0, or x is equal to 1, and otherwise we're going to return x times factorial. See, we are calling the function from inside of itself, x minus 1, and then we can come down here and get our results. So let's say we wanted the factorial of 4, and I'll explain exactly what's going on here in a second. And we can come in and go factorial and pass in 4 as our default value and reload it, and you can see that it comes back with 24. So what exactly is happening here? Well, basically, whenever it very first starts off, we're going to pass in a value of 4, which is ultimately going to be multiplied times factorial of 3. Factorial of 3 is then going to call the factorial function again. Here we're going to get 3, and then we're going to call factorial of 2. Then we're going to pass the 2 down here, times factorial of 1. Factorial of 1 is going to return the value of 1, and that's what you can see right there. Then you have the 2 right here. This final value of 2 is going to go up the loop. Then you're going to have 3, which is going to give you a value of 6, which is then going to get transferred up here, which is going to be multiplied towards the original 4, which is going to give us a final value of 24. So that's how factorials work inside of CoffeeScript. So there is a basic rundown of functions along with all the other little things that I showed you previously in the tutorial. Now we're going to take a look at objects. Alright, so let's start off with a basic object. We'll just call this Derek, and you can also come in here. I know I've defined objects in different ways not using commas. You can also come in and use commas if you would prefer that. So I could say 41, and then I could say street, and 123 Main Street like this. So you saw all the different ways to create basic objects. We're then going to be able to come in here and get some information. So let's say we wanted the name for this object. We would be able to come in and just go Derek.name, output that, and you can see that it shows up just like we would expect it to. We could also go in and add object properties quite easily. So we can just go, so let's say that we decide we want to put a state inside of here. We can do so, and there that is. And then we could cycle through our object. We could say for x, y of the Derek object, and output information. And then we'll just keep this simple. We'll say x is y, and then keep our break statement here at the end. And name is Derek, age is 41, street is 123 Main Street, and state is Pennsylvania. As you can see, there is the Pennsylvania part. And there's a basic overview of just rough objects. Now I'm going to jump over and show you how to define your own using classes. Okay, so let's say that we want to create a class inside here, and a class is just a blueprint for creating objects. You're going to have your attributes, which are the things that define your object, and then you're going to have your capabilities or functions, which are going to define what your object can do. Now, to define your properties, which are the things that describe your object, you're just going to start listing them right in the very beginning. No semicolons, no nothing. So we'll just have height, and I'm going to give all these things default values. So those are all of my properties for my animal class objects. You can also define a static property that's going to be shared by all of your objects, and that means if the value changes for one object, it's going to change for all of them. And let's say that we want to have number of animals, and we want to give it a value of 0. Now, the reason why this is static is because we have animal objects we are creating. Number of animals is just going to continue to increment each time we create a new animal. Now, would it make sense for our animal objects, since they are modeling real-world objects, to be able to count? No. That is the reason why they are static. And you can see that we specifically show that they are static by putting in a little @ sign there. We can also have static methods. Once again, if it doesn't make sense for our object that we are modeling to be able to do something, we will make it static. And we are going to define our static methods by putting an @ sign in front of them. This guy isn't going to receive any attributes. And if we want to specifically call a static value of the animal class, we have to start with animal and then num of animals, right, like this. So this is just going to return the value for num of animals anytime this method is called. We're also going to be able to define constructors, which are going to be called when an object is created, and it's used for initialization purposes. And to define a constructor, we're going to say constructor, and then we're going to define some different attributes. Now you can do this in a couple different ways. We could set a default value, for example, if nothing was defined inside of here. We could also come in and type in, well, let's just keep it like this here for a second, just so I can show you how cool this is. Now, under this situation, we would receive a name, and we would assign the name to our new animal object we just created. Now, we would use @ like most programming languages use this to specifically target this object that we are creating, and we're going to assign the name like that. Now you would think, well, I'm going to have to do the same thing for height and weight and sound and all those other different things. Nope, there's a shortcut. If you come in here and you would put @height is equal to 0, for example, that is saying right here that you want this to occur on its own automatically. So there's a shortcut for us. And then we could also come in and do the same thing for weight is equal to 0, given it a default value. And then you're going to put your little arrow inside of there like that, just like you always have. Put that on a separate line to make a little bit more sense. Now let's say since we created a new animal, we want to increment the value for number of animals. To do that, we're going to have to define the class name and then say number of animals and increment it. So that's how we would increment a static value inside of a class. We're going to be able to create regular old class functions. So we could have make sound, for example, put our arrow symbol inside of there, and we could just say says. And then if we want to get this specific object's sound, we put the @ symbol inside of there. And let's go and create another one. Let's call this one get info. Throw an arrow inside of there. And we could do something a little bit more complex. We want to get the specific name for our object. We do it that way. Is, and then we could get the weight for our object, centimeters and weighs, and get the animal object's weight. And then if we want to call a function, we just go @make sound like this. Alright, so we defined our classes and our static attributes and our methods and all those other different things. Now let's create an object. To do so, you would just say Grover is equal to and new animal, and there you passed all that in. We could then come in and define specific values for Grover. So Grover name is obviously equal to Grover. Grover height is equal to 60. Grover weight is equal to 35, and Grover sound is equal to, well, let's put this, make this a string, wolf. We're then going to be able to call the getInfo function right there so that we can output all the information that we know about Grover. And to do that, we just go grover.getInfo, save it, reload it, and we got a little bit of an error. Good thing we got it though, because I made a mistake here. White space, very, very important inside of CoffeeScript. We want to make sure that everything is indented properly. There we are. Save it, reload it, and now you can see Grover, 35 centimeters, weighs 35 kilograms, and says wolf. And you can see that all of our methods we have defined here are all lined up properly. So just to reinforce the fact that CoffeeScript is very dependent upon white space and using it properly. Now we're also going to be able to come in and attach new object methods outside of our class if we'd like to. So to do so, you just go animal, : so we could say something like is it big to see if our object is actually big or not. And then we could just say if @height is greater than or equal to 45, we're going to return the value of yes. Else we will return the value for no. And then we could come in, find out if Grover is considered big or not. Is Grover big? And then call Grover, is it big? And you can see that yes, Grover is considered to be a big animal. And then also if you wanted to get the total number of animals that have been created, which is going to call that static function of ours, go number of animals. And to do so, once again, we're going to use the class name because it is a class method that we're going to be calling. And then get number of animals, that, reload it, and number of animals comes back as 1. So there's an overview of classes. Now let's take a look at inheritance. Now we're going to leave our animal class here because we're going to be inheriting from it. And of course, with inheritance, each class that extends another is going to receive all of its properties as well as all of its methods. So to inherit, let's say we create a new object called dog, and it's going to inherit or extend the animal class. That's how that's done. We could then come in and define new properties. Say this has a default value of no sound. we're going to come in and create a constructor once again. Name is equal to no name. Here we're going to not use the @ symbol because I'm going to show you something different again, just like we used previously with our constructor. We're then going to be able to call our superclass constructor. And to do that, we just go super, followed by the information we want to pass into the constructor. Let's put this in the proper order. So there's height and there's weight. And this CoffeeScript's smart enough to know that since the super is inside of the constructor, that it wants it to pass this information up here and process all that information up there. So that's how you call the super part, or the superclass. If we would like to come in and override a function, we just define a function with exactly the same name, and CoffeeScript's intelligent enough to know that we want to call that. However, we can call the super version of make sound, this guy up here, quite easy, just by typing in super, and it's automatically going to work. And then we could say something like and throw our new sound inside of here that only the dogs have. And now we can come down and define a new dog object, Sparky, new dog. And let's just pass in Sparky as our name for our new dog object. And we could say Sparky sound is equal to, let's give him a very big woof. And then we could define his second sound as grrr. And now, if we want to go and call this to see the changes that have been made, we can just say Sparky and call the original get info and reload it. You can see there's no height or weight information because we didn't pass that in, but it automatically went in and print out the two different types of sound that Sparky makes. Okay guys, so there's pretty much everything you'd need to know basic syntax wise in regards to CoffeeScript. Start writing programs in it. And before I left, I just wanted to send out a special thank you to the 18 people that are supporting me on Patreon. I thank you very, very much. You guys are the reason why I'm going to be able to continue making educational videos on YouTube. And if anybody's wondering why I went on Patreon, I earned about $3.49 off of 8 videos, so I knew that based off the changes going on with YouTube, if I wanted to continue making these videos, I'd need to look for other funding sources, and these 18 guys helped out a lot, and I just once again wanted to say thank you. So just like always, please leave your questions and comments below. Otherwise, till next time.